Hello, let's understand DC to AC conversion. After studying DC to DC conversion, in DC to AC conversion, our main aim is to convert fixed DC voltage into produce sinusoidal waveform of either 50 or 60 Hz depending upon the required frequency. But very basic form of converting DC to AC is converting DC to the square wave. Even square wave is not pure sinusoidal wave with lots of harmonic. You can consider it the sine wave with the higher inductance and the circuit impedance. We can convert DC to AC with the help of square wave. So it is suitable for ideal resistive load and some load with very less inductance. But for the motor and fan, this type of inverter is not suitable as square wave contain lots of harmonics. So let's see converting the DC to AC in simple square wave inverter. So here we require the 4 switches. We have selected the MOSFET here. 230 volt is supply. Generally MOSFET is suitable for the 12 volt, 24 volt or 48 volt lower voltage. But we have selected any random voltage, 230 volt, it's fine. Let's see how it's work. This is our load. Here resistor load is there. Small amount of inductance is 0.1 millihenry and 10 ohm is resistance. So to convert the DC into square wave, we require the 4 switch. When switch M1 and M4 both are turned on, it is pair supplied by the same gate signal. So when these 2 switches are turned on, the voltage across load will be VDC, that is 230 volt. And when the 2 switches M2 and M3 are on, the voltage across load will be inverted with compared to previous, so we can treat it as the minus VDC. So current will flow like this when M1 M4 are on, or like this. So current will have either this direction or either reverse direction in this condition. We are having only 2 conditions of state, either M1 M4 simultaneously on or M2 M3 are on. So to generate the gate pulse, we require this kind of arrangement, so we can generate the one pulse which can turn on these 2 signal. And how long it will remain on, because we require the 50 Hz, total cycle is 0.02 second. For the 50 Hz, we require this M1 and 4 gate pulse G1 should be higher or should be at the high level for the 0.01 second, and 0.01 second it should be off. So here also requirement is also we need to generate gate pulse of square wave with the 50% duty cycle, and the total time period is 0.02. If we see the pulse G1, magnitude is 5, you can also select the magnitude 1, it doesn't matter because the gate terminal of MOSFET is not actual, it is ideal and only logical gate terminal. We are not applying across GS also, so you can use 1, it will also turn on, but less than 1 it will not turn on, 1 or higher. Period 0.02 second, you can see here second, and pulse width is 50. So for 0.01 second it will remain high, and for rest of 0.01 second it remains off. So phase delay is 0 for the G1. Now the totally reverse we require here, so we can use either NOT gate or better we use the second pulse generator to generate the pulse for switch M2 and M3. So when we use the phase delay of half the total period, so 0.01 second. So this pulse will be started after 0.01 second. That means it will be complement of gate pulse 1. All other things remain same for the G2, only the phase delay of half then total period 0.01 second. So now if we turn on the circuit, we will have the scope which can measure on the single plot G1 and G2 both gate pulse, output voltage, load current and source current. So if we run it for 1 second, you can observe till it is in continuous mode, so fast simulation will be there, and we can observe. You can see output voltage, it's maximum voltage is 230, and gate pulse. These yellow ones are G1 and this is G2. So when G1 is on, voltage is positive. When G2 is on, voltage is negative. Current is also same. You can see inductance is small, so current is also like the square, but if we zoom it, we can see there is inductance effect. When voltage is applied, the current increase slowly. But in this you can see current and voltage both are like square wave. And source current is almost constant, only transition effect we will see over here, not here, because in the both the case, see, only during transition negative current is there. So either current is flowing through M1 M4 or M2 M3, source current will remain in same direction. Further, we can check the effect of inductance by increasing it some further larger value to just observe the only. Let's run it and have a look at inductance effect. You can see now current is having effect of higher inductance and it will look like this. So this is simple square wave inverter, very useful for the very low cost application, and where only resistive load is there, or lamp or bulb or light, we can also use it. But it is not suitable for the like to run the CPUs, desktops, fans. So harmonics will be there. This is the starting from where we can understand the operation of inverter converting DC to AC in single phase.